Hello everyone, today we are going to implement clear method in our DoublyLinkedList implementation. Format is same. First we will do the pair programming, and then after that we will execute, and then we will analyze the time and space complexity. Clear. So in this case, our expectation and the client's expectation will be list will be null. So if you guys remember, in case of a singly linked list, what we did head equal to null, tail equal to null, and size equal to 0. That is what we did, and this is a big of one operation in case of a singly linked list. But in case of a doubly linked list, there is a problem. And what's that problem? We can try to visualize. Otherwise I will share with you on a whiteboard. It's pretty difficult to show you, but still we will try first. Okay, so in this case what we will say, okay, I have a list. I will call list dot clear, and then we'll see. So after it's really saying it's null, but is it really null? So we are here. I have this head, tail, size. Okay, so first attempt, head equal to null, yes. Then tail is equal to null. Yeah, it look like now GC is ready to collect this list, but there is a problem. And the problem is, once the next node, in our case we have a loop, next node and previous node. So once GC will take, for example, one node, and it will check is any other object is referring to that node, and the GC will get the answer yes, someone's previous node is referring to this. Okay, then GC will say okay, no one is, it means it's not ready for the garbage collection, and GC will move to the some other node, and then there is the same pattern. Yeah, in case of, for example, a special case, if I have a list of value one node, which means like user used our list, he added only one value, for example 10, and then after that we call clear head tail size. In that case this will work. It's a big of one, because in that case my next and my previous both are null, no one is referring to that object, so GC can collect. But in case if I have two values and I will say head null, tail null, in that case still those two nodes are referring to each other, so GC can't collect. So what we can do, one thing we can do, for example, there are multiple approaches. Okay, I'm doing one experiment. For example, if I say while is not empty, remove first. So in this case what will happen, okay, to make sure to check everything is working, only I'm writing a one extra line so we can confirm. So now we are at line this, it means head should be null, tail is null, size is equal to 0. Why this happened? Because remove first will remove until everything is, so this is a big of one operation, a big of an operation, but reusing. In a same way I can say okay, remove last, or maybe I can say okay, remove at, and I can start for loop from the size -1 going from end to start, or any other way. Or I can implement the same thing on my own. So I can take a one node, just like how we are implementing here, or maybe this one. So taking one node at a time and then doing this stuff the same. So I think, in my opinion, this one looks good to me. Is there any issue? I don't see any issue. What can go wrong? So size is already taken care by the remove first. Remove first is also taken care by the null of tail, head. So to me it looks like good. It's a big of an operation. And anything else we need to improve to, so yes, head, tail, size, everything we need to go. So yeah, that will be a clear method. Welcome back. So we can start. So mainly there are we can say two use cases, not edge cases, two use cases where we can discuss around this clear method. So if you guys remember, in the singly linked list it's always big O of 1, but in case of a doubly linked list there are two flavors. So we will see. First I will create a one size is equal to 1. So I created a one linked list, doubly linked list with size 1. So it means I have only one value. In this case, head is this, tail is this, and that is done. And in case if I write in my clear method head equal to null, tail is equal to null, size is equal to 0, only in this case when we have a one node everything will work, because currently next node and previous node are null. So once I will do this, it's 0 and it's ready for the GC, garbage collection. So we are done. So that is a big O of 1 operation, but that is a special case. So when we have only one node, but once, for example, I have two nodes or three nodes, 2 and 3 are all same, but I can write 3, so it will be more easier. So I have first node, then I have second node, and then I have third node. So this one is first node, second node, its previous is this, and okay, it may create more confusion, so I will write here. So next and previous, and this one is null, head is there, tail is this, size is 3. So in this case, imagine I'm saying okay, head null, tail null, and size 0. Now what will happen? As per my knowledge, we have a memory leak, because GC is not able to collect this. Once GC will come and it will check a reference, okay, anyone is accessing this, no one is accessing this, okay, it's ready to access. But once the GC will ask to this, hey, are someone referring to you? And it will say yes, the one is referring to me, and 2 is also referring to 3. So GC can't collect. If we have only kind of a singly linked list, next, in that case GC will not collect 3, because when it will ask to 3, anyone is referring to you, 3 will say, in case of a singly linked list, okay, I'm making a simple singly linked list, 1, 2 and 3. Okay, so this is a singly node, this one is head, and I did head equal to null. At this point when GC will come, it will check 2. So 2 is, anyone is referring to 2, yes, 1. It will come to 1. Anyone is referring to 1, no. GC will take all this singly linked list. In this case, as per my understanding, it will check anyone is referring, 1 is referring to 2, which is okay, but any other node is, or any other pointer or reference is referring to 1, it will say yes, 2 is referring to me. In that case, GC will say I'm not able to collect you. So in that case, what we need to do, remove all these one by one. So you can go by one, okay, take this head as a current and do a loop until end, or you can call our remove first method or a remove last method or remove at index, because that will do the same thing. So by calling remove last every time, what I am doing, okay, I am saying okay, remove this and head move to this, and we have a while loop which is empty, is not empty, which depend on this size. So now size is remaining 2, still not empty, because we have a check empty if size equal to 0. It will say okay, remove this, and we are now here, it is now 1. At this point, if I do head and tail equal to null, that will work, but now it's a null loop. What we're saying, okay, remove first, it will remove this, In this case, in our remove first, we have a check. It will do null because this one is now 0, and we also have a check. You can go back and revise that video. If is empty, do tail equal to null. So in this case, everything works. There is no memory leak. But in this case, we have a big O of n. N means the number of nodes. So that is our clear method implementation. From the space complexity wise, we are not taking any extra space. It's same what is the implemented already. So yeah, there is only time complexity which will go is the big O of n. So I hope we learned something new. See you in the next video. Bye.